Hello students, today we are going to discuss reduction formulae in this particular unit number 3. So what is reduction formulae? Reduction means reducing the index. What we do here, we try to develop reduction formulae for sine raised to nx dx, cos raised to nx dx, tan raised to nx dx, cosec raised to nx dx, sec raised to nx dx, and so on. So what is the use of this? In fact, if you need to find value of this integral, you can use half angles here, 1 minus cos 2x divided by 2, and we integrate by the traditional method and get the value of this, or integral of this particular expression. But if you need to find sine raised to, say, more index for, it is something, say, sine raised to 100x, then it is quite complicated job. Or if it is cube or raised to 4, raised to 5, it is rather complicated. So what we do, we try to develop reduction formulae for n which is greater than 0, and we can find out value for any index, especially if you are having the limits 0 to pi by 2. Most of the integrals are reduced to this particular form, 0 to pi by 2, some cos raised to some index there. Then we develop this formula. This formula is developed by certain rules there, by reducing the index, and we can find out value of certain integrals. So formulas for 0 to pi by 2 sine raised to nx, 0 to pi by 2 cos raised to nx, it is this same formula in fact for even and odd positive integers. So it is n minus 1 upon n minus 3 upon n minus 2, and so on. Finally it is half, it is starting from pi by 2, half 3 by 4 if n is even positive integer, and here it will start from 1, 2 by 3, 4 by 5 if n is odd positive integer. If it is product of sine and cosine, and if you need to find the formula m and n, m greater than 1, n greater than 1. So the formula is something like this. Here it is multiplied by some value p here, where p is equal to pi by 2 if m and n even positive integers, and this is equal to 1 if otherwise, means for the rest of the combinations, m odd, n even, both are odd, m even, n odd, and so on. Rest of the three combinations there. So this is the way we apply this particular formula. Now suppose I would like to find value of 0 to pi by 2 for some instance, say sine raised to 4x dx. Then I apply this formula here, this formula sine raised to 4x, this formula. Now n is equal to 4, means it is even positive integer. So I just apply this particular formula here, n is equal to 4, it is even, so this formula 4 minus 1 upon 4, 4 minus 3 upon 4 minus 2, and next, so this value is 1 by 2, and last multiple is 5 by 2. So you are getting this as 3 by 4, then 1 by 2 into pi by 2. So within 1 minute you can get value of this integral. It is 3 pi by 16 over here. Similarly, if you need to find value of, say, 0 to pi by 2 cos raised to, say, 5, cos raised to 5x dx, then it would be something, this formula it is applied, because n is equal to 5, it is odd positive integer, so I just use this formula here, 5 minus 1 upon 5, 5 minus 3 upon 5 minus 2, and this value, the next value, 5 minus 5, it becomes 0, so need not be considered. So this is 4 by 5, then it is 2 by 3, and this one last is 1, so 8 by 15 is the value. So this is the way we can apply for even and odd positive integers these reduction formulas. Similarly, if you are having product, to apply second formula, if you are having something like this, say 0 to pi by 2 sine raised to 4x cos raised to say 5x into dx, then naturally product of sine and cosine, m is equal to 4, n is equal to 5. So this formula, there are three brackets, first bracket, second bracket, and the third bracket, and the value of p to be considered here. So p, it is taken as 1 because this is even, this is odd. If it is even or odd, the value of p is equal to 1. So we apply the formula then. So in the first bracket, it is something m is equal to 4 means 4 minus 1 from here, 4 minus 3, 4 minus 3, 4 minus 5 is not valid. I close the bracket. The next one, it is n means 5. 5 minus 1, 5 minus 3, 5 minus 5 is not valid. Then it is closed here, divided by m plus n means 4 plus 5, it is 9. Then 9 minus 2, then 9 minus 4, then 9 minus 6, then 9 minus 8, 9 minus 8, and next 9 minus 10 is not valid, and value of p is equal to 1. Now we simplify this and get the value. It is something 3 into 1 in the first bracket, second bracket it is 4 into 2, 4 into 2, and next bracket it is 9 into 7 into 5, then it is something, this is 3 and 1 and multiplied by 1. If you simplify this, then you are getting something, 3 gets cancelled here, then here you are getting 2, 4, it is 8, 8 divided by something 63 into 5. So this is the value of this particular integral. So this is the way you can apply this formula for product of sine and cosine. Now similarly, if you would like to solve certain problems or certain integrals based on this, it is reduced to the integral 0 to, suppose I would like to find, evaluate the integral, say 0 to 1 x raised to 5 divided by root of 1 minus x square into dx. Suppose you need to find value of this integral, then naturally if it is 1 minus x square, so we use the substitution, put x is equal to sine theta. Sine theta is the substitution there because 1 minus sine square, it is cos square. If it is plus sine, then it is tan substitution. So dx is equal to cos theta d theta. And limits we find out. So limits for x is equal to 0 from here. Sine theta 0 means theta is equal to 0. So theta is equal to 0, one of the value. Then for 1, sine theta 1, so theta is equal to pi by 2. So automatically you are getting the limits 0 to pi by 2. Then we transform this integral in this form, 0 to pi by 2, 0 to pi by 2, x is equal to sine theta bracket raised to 5 divided by root of 1 minus sine square theta multiplied by dx. Dx means it is cos theta d theta. Now this gets cancelled from here, and you are getting 0 to pi by 2 sine raised to 5 theta into d theta, and this is readily our standard form there of the reduction formulae. So we can find value of this by the earlier formula I told you, n is equal to 5, it is odd positive integer, So we apply the formula 5 minus 1 upon 5, 5 minus 3 upon 5 minus 2, 5 minus, so it is 1, so you are getting 4 by 5, 4 by 5 multiplied by 2 by 3 multiplied by 1, so 8 by 15 is the value of this particular integral. So this is the way it is value of these integrals will be obtained there of this particular form. Now next is, suppose you are having some more integrals, say 0 to 2 times a. Evaluate this integral x into root of 2 times ax minus x square into dx. Suppose you need to find value of this integral, then we write down this integral in the form 0 to 2 times a. I take x outside the radical sign, so it is x into root x, so it is in the radical sign 2a minus x into dx, 2a minus x into dx. Now this is x into root x is 0 to 2 times a, it is x raised to 3 by 2 and root of 2a minus x into dx. So suitable substitution for this is, in order to have this 1 minus sine square, so I put the substitution 2 times x is equal to here 2 times a can be taken outside and some other variable, it is t, 2 times a, so that, or it is sine theta, t also can be taken for gamma function or beta function. So dx is equal to 2 times a cos theta into d theta. Now I substitute this and the limits would be something for x is equal to 0 from this expression, sin theta 0 means theta is equal to 0. If you put upper limit x is equal to 2a, x is equal to 2 times a if you are putting, then 2a gets cancelled, sin theta 1 means theta is equal to pi by 2. So this is readily you are getting the standard limits there, 0 to pi by 2. So this will get transformed, I call this as I integral. So from 1 you are getting the integral I is equal to, with new limits, 0 to pi by 2, x I put there 2a sin theta bracket raised to 3 by 2 root of 2 times a minus 2 times a sin square theta we are taking here, the substitution, sin square theta here. So it is 4 times a sin theta cos theta d theta. Cos theta sin theta, so that it is sin square theta. So I use the substitution, I put it here 2 times a sin square theta, 2 times a sin square theta, and this one it is 4 times a sin theta cos theta d theta, sin theta cos theta d theta. Now this one I take all the constants outside, so it is 2 times a bracket raised to 3 by 2 from here, then from here 2 times a bracket raised to half, then here it is 4 times a, and inside the bracket it is 0 to, inside the integral sign it is sine cube theta. If you simplify this, sine cube theta, and root of 1 minus sine square theta, it is cos theta, and multiplied by here sine theta cos theta d theta. So it is something, so this is plus, this is, it is something 2 times a bracket square you are getting bracket square into 4 times a, and here 0 to pi by 2 on simplification, cos square, so it is sine raised to 4 theta cos square theta d theta. Now apply the reduction formula for this. It is m is equal to 4, n is equal to 2. So I apply the reduction formula, and this would be 4a square multiplied by 4a multiplied by, now here we apply the reduction formula for the first bracket. It is 4 minus 1, 4 minus 3, and next bracket it is 2 minus 1, and value of p, it is naturally pi by 2 because both are even positive integers, and divided by, it is something 4 plus 2 means it is 6 minus 2, 6 minus 4 multiplied by pi by 2. So we simplify this. So this is 16a cube multiplied by 3 into 1 divided by 6 into 4 into 2. So multiplied by pi by 2. So we simplify this. This most probably this something 3 2s are 6, 8, this one 8, 16 means this 16 gets cancelled with this, and you are getting pi a cube upon 2 is the final answer. So here the substitution to be taken as sine square instead of sine, because 2a minus x if it is there, 2a taken common, sine square, 1 minus sine square, it is cos square. So this is the type of the problems based on this formula. The next is, suppose you need to find value of the integral, or we develop reduction formulae for sine and cos. Sine, cos, tan, cosec, sec. Suppose the next example, it is this: find reduction formula for the integral un is equal to 0 to pi by 4 tan raised to n theta d theta, and hence find u3. Now if you observe here, to find reduction formula for this, or connecting this reduction formula in with in minus 2 or un with un minus 2. So solution for this, it is given un is equal to 0 to pi by 4 tan raised to n theta d theta. Now one thing you have to remember here, that while reducing the index, if tan cot cosec is there, tan cot cosec sec if it is there, then index to be reduced by 2, and if it is sine cos is there, then index to be reduced by 1. So we reduce index by 2, 0 to pi by 4 tan raised to n minus 2 theta into tan square theta. Note this very important step here. So this is important step, reducing index by 2. Now what we do further, 0 to pi by 4 tan raised to n minus 2 theta, tan square means it is sec square theta minus 1 into d theta. Then I will write down this in the form, splitting the terms there, 0 to pi by 4 tan raised to n minus 2 theta into sec square theta into d theta minus 0 to pi by 4 tan raised to n minus 2 theta into d theta. Now we integrate this. So if you integrate this, then we use the formula. This is f this is f dash. So we are using formula f into f raised to n, in fact. So f raised to n into f dash, this is equal to f raised to n plus 1 upon n plus 1. This formula we are using. So I will write down this as tan theta bracket raised to n minus 2 plus 1 upon n minus 2 plus 1 and limits applied 0 to pi by 4 minus, now I can write down this un, if it is there, un minus 2, naturally n is replaced by n minus 2, so 0 to pi by 4 tan raised to n minus 2 theta into d theta. So I can replace this for un minus 2, and this would be limits applied 0 to pi by 4 minus un minus 2. Now, if you apply the limits there, then it would be tan pi by 4. It is 1, tan 0, 1. So it is 1 upon n minus 1. And for 0, it is 0. So need not be considered. Minus un minus 2. So this is un, and the formula we have developed for this, it is un is equal to 1 upon n minus 1 minus un minus 2. So this is required reduction formula for 0 to pi by 4 tan raised to n minus 2 theta, tan raised to n theta with respect to theta. Now if need to find u3, so how to get u3? Just you are putting value of n to be 3 and just go on recurring that value and get that u3 or u4 or u5 or u6 you can work out. un, this is equal to 1 upon n minus 1 minus un minus 2. So put n is equal to 3. Put n is equal to 3. So what will happen here? It is u3 upon here 3 minus 1 minus u3 minus 2 means u1. So it is u3 is equal to 1 upon 2 minus u1. But u1 from the original integral, un is equal to 0 to pi by 4 tan raised to n theta d theta. So u1 naturally by putting n is equal to 1, 0 to pi by 4 tan raised to 1 theta d theta, and integration of tan is log of sec theta and limits applied 0 to pi by 4. So value of u1 you can get from here, theta is equal to pi by 4, sec pi by 4, it is root 2, so log of root 2 you are getting, minus sec 0 it is 1, means log 1 you are getting, log 1 to the base e it is 0, so log of root 2 you are getting the value of u1. Substitute this value here, therefore u3, that is value of the integral 0 to pi by 4 tan cube theta d theta, this would be 1 by 2 minus log of root 2. So in this way you can just find the value for any n. N is equal to 4, suppose you need to find u4, then put n equal to 4, 1 upon 4 minus 1 means 1 by 3, then it is 4 minus 2 u2, again you can find out u2 from here, it is u2 1 upon 2 minus 1, then 2 minus 2 means u0 you can just calculate from here, raised to 0 means 1, so value of u0 is pi by 4 you are getting. So likewise you can find out value of any n there, any index there for this particular using this particular reduction formula. Now similarly you are having reduction formula for sine also. Sine, find reduction formula for 0 to pi by 3 cos raised to n theta or x connecting un with un minus 2, connecting un with un minus 2. and hence find u3 or u4, you can find out any value. So I consider solution for this. Given un is equal to 0 to pi by 3 cos raised to n theta d theta. So as I said earlier, sine cos, if it is there, it is index to be reduced by 1. So 0 to pi by 3 cos raised to n minus 1 theta cos theta. So this is, again I told you earlier, this important step over here. Now we apply by parts here. Direct integration is not possible, so you apply by parts. You know what is by parts? Integration of u into v d theta. This is equal to u into integration of v, and suppose some limits are there, v a to b. So it is this. Then a to b minus a to b integration of v into du by d theta. So something like this, you are just applying the by parts there. So I just keep this one as it is, cos theta bracket raised to n minus 1 as it is. Then integration of cos theta is sin theta, limits applied, 0 to pi by 3 minus integration 0 to pi by 3 sin theta as it is, because it is already integrated, and derivative of first function n minus 1 cos raised to n minus 1, it is cos raised to n minus 2 theta into minus sin theta into d theta. So we apply the limits there. Now this is equal to upper limit, cos pi by 3 is cos 60, it is 1 by 2, cos 60, it is 1 by 2 bracket raised to n minus 1 is sin 60, root, it is root 3 by 2, then minus 1 by 2 bracket raised to n here. Then next is minus here, plus it becomes this n minus 1 is taken outside. Then 0 to pi by 3, then this sin square, so cos raised to n minus 2 theta into sin square theta, like this you are getting on simplification. So this is 1 upon 2 raised to n root 3 by 2, and lower limit, its value naturally it is 0 because sin 0 is 0, plus n minus 1, and here we replace this sin square by 1 minus cos square, because we are finding formula for cos. So we replace this, and on simplification you may be getting this. If you multiply with this, then cos raised to n minus 2 theta d theta, then minus n minus 1 integral 0 to pi by 3, then this is cos raised to n minus 2 and cos square, it is cos raised to n theta d theta, cos raised to n theta d theta with n minus 1. Now if you observe this, this is for un. So it is un is equal to 1 root 3 upon 2 raised to n plus 1 plus n minus 1. Now I make the replacement. So this is, so I un minus 2, naturally it is 0 to pi by 3 cos raised to n minus 2 theta d theta. So I replace this un minus 2 here, and minus n minus 1. So this is un. So I collect the terms of un. I just take this term on that side. So it is un plus n minus 1 into un. This is equal to root 3 divided by 2 raised to n plus 1 plus n minus 1 into un minus 2. Now if you simplify this, un taken outside, so plus 1 minus 1 gets cancelled. Then un is equal to, take this n on this side, so root 3 upon 2 raised to n plus 2, and plus 2 raised to n plus 1, 2 raised to n plus 1 into n, 2 raised to n plus 1 divided by n, and this one is n minus 1 divided by n minus 2. So this is reduction formula for 0 to pi by 3, 0 to pi by 3 cos raised to nx, connecting un with un minus 2. Similarly, you can find out u4 by putting n is equal to 4 over here and recurring it, u4 then root 3 2 raised to 4 means something like this, and that is the reduction formula for cos and sine. Also the same technique it is to be used to get the reduction formula. Now let us develop reduction formula for sec also. Reduction formula for sec. Find or develop, find reduction formula for integral 0 to pi by 4 sec raised to n theta d theta, connecting un with un minus 2, and hence find, say here, let us find u6 now, u6. So let us see what is happening of this reduction formula. Solution, given un is equal to 0 to pi by 4 sec raised to n theta. You can develop formula for cosec also by same technique to be used there. So this is equal to 0 to pi by 4 sec raised to n minus 2, as I said right now, sec square theta d theta, reducing index by 2, tan cot cosec sec by 2, sin cos by 1. So this is important step. Note this underlying expression very carefully. Now we just integrate this sec raised to n minus 2 sec square theta. We just apply by parts here, u into v, because integration of sec square is possible. Directly you can write down it as tan theta over there. In case of tan it is not possible, so we replace tan square by sec square minus theta and so on. So it is u by parts, as I said earlier, by parts u into v. It is u into integration of v minus integration of v into du by d theta and so on. So this by parts we apply, sec raised to n minus 2 theta, constant, integration of second function, it is tan theta, and limits applied, it is 0 to pi by 4, minus integration 0 to pi by 4 tan theta, as it is, no change. Now integration of sec raised to n, differentiation of sec raised to n minus 2, it is n minus 2 sec raised to n minus 3 theta into differentiation of sec theta, it is sec theta into tan theta into d theta. So we apply the limits now. So this is equal to pi by 4, sec pi by 4, as you know earlier, it is root 2 bracket raised to n minus 2, and tan pi by 4, it is 1. So need not be, and for 0 tan 0 is 0, that's why it is 0 the whole term. Now I take this n minus 2 outside and simplify this further. This would be 0 to pi by 4. Now see what is happening of this. This is tan square, and this one is sec raised to n minus 2 theta into tan square theta d theta. Now tan square I have to replace sec square theta minus 1. So this is equal to root 2 bracket raised to n minus 2, and minus this one, I replace this is by sec square theta minus 1 and simplify. So on simplification you may be getting this as 0 to pi by 4 sec into sec raised to n minus 2 sec square, means sec raised to n you are getting, sec raised to n theta d theta, and this minus minus plus you are getting n minus 2, n minus 2, minus minus plus, and sec raised to integration 0 to pi by 4 sec raised to n minus 2 theta d theta. Now this one for un. So un is equal to root 2 bracket raised to n minus 2 minus n minus 2, and this one is un, this is un. Now this one is un minus 2 from the original integral. So un minus 2, naturally it would be just replacing n by n minus 2. So it is sec raised to n minus 2 theta. So we can replace for this, it is un minus 2 plus n minus 2. This is un minus 2. Now I collect the terms of un and un. I just take this term on that side. So un plus n minus 2. So minus becomes plus there, un, and this is equal to root 2 bracket raised to n minus 2 and plus n minus 2 into un minus 2. Now if you simplify this, this is n minus 1. So un is equal to, take this n minus 1 on this side, n minus 2 divided by n minus 1 plus n minus 2 divided by n minus 1 un minus 2. So this is your required reduction formula connecting un with un minus 2. Now you need to find u6. So how to calculate u6? Just you are putting n is equal to 6 there and go on recurring and get the value of u6. So I just go on putting this value there, n is equal to 6 and remaining values. So put n is equal to 6. I may be calling this as expression 1. To get u6, to get u6, put n is equal to 6 in 1. So what happens if you are putting n is equal to 6? u6 is equal to root 2 bracket raised to 6 minus 2 means 4 divided by 5. 6 minus 1 is 5 plus 6 minus 2 is 4 divided by, this is again 5, and u6 minus 2 means 4. So this is actually root 2 bracket raised to 4, means it is root 2 square, means it is 4 by 5 plus 4 by 5 u4, and this is u6. Now u4 again I have to calculate from expression 1. So to get u4, I call this is 2. To get u4, so this technique is used every time. Just go on putting the values of n there. So put n is equal to 4 in 1. So what happens there? u4 you are getting, u4 here, u4 you need to find this. So root 2 bracket raised to 4 minus 2, it is 2 divided by 4, this is 3 plus 4 minus 2 is 2 divided by 3, then n is equal to 4 if you are putting, then u2 you are getting. So u4 you are getting as this 2 by 3 plus 2 by 3 into u2. Now how to get u2? Again the same thing, put n is equal to 2 there and get the value of u2. But u2 from 1, u2 is equal to, from here it is raised to 0 means 1, 1 by 1, 2 minus 1. So here the next would be 0 because 2 minus 2 0 there. So u2 is 1 actually, u2 is equal to 1. Substitute this value here, u4. So u4 would be naturally, it is 2 by 3 plus 2 by 3 into 1 means it is 4 by 3. Okay, this is u4. Now substitute this value in 2. So from 2 you are getting, from 2 u6 is equal to 4 by 5 plus 4 by 5 into u4 is 4 by 3. So if you simplify this, this is 28 by 15 is the value of u6, and u6 means in fact value of this particular integral. It is 0 to pi by 4 sec raised to 6 theta d theta. This is equal to 28 by 15. So likewise, you can apply the reduction formulas effectively for sine cos by reducing index 1, tan cot cosec reducing index by 2, and similarly if it is desired to use the first two formulas, then you have to use proper substitution and get it in a proper form and use the formula for 0 to pi by 2. Most of the integrals are reduced to the form 0 to pi by 2 sine raised to m cos raised to n, or 0 to pi by 2 sine raised to nx cos raised to nx, and get the required reduction formula over there. So the next example here on the reduction formula is if In is equal to what is the time?
11:20.
Huh? 10
minutes.
10 minutes. Okay. If In is equal to 0 to pi by 2 x raised to n sin x, then show that In is equal to n pi by 2 bracket raised to n minus 1 minus n minus 1 In minus 2. So let us see how to prove this, how to obtain this reduction formula for this particular integral, which is product of algebraic multiplied by trigonometric function. Given In is equal to, it is 0 to pi by 2 x raised to n sin x dx. So I would like to connect this In with In minus 2. So I will write down In minus 2 also. In minus 2 is something like this, 0 to pi by 2 x raised to n minus 2 into sin x dx. It is something like this. This is 2 and this is 1. Now I would like to obtain this formula from this. So this means In minus 2 x raised to n minus 2. I must differentiate this and I must integrate this. So I take this as u and this as v and integrate by parts. So integration by parts. So what happens, see, this is equal to x raised to n constant, integration of this minus cos x and limits applied, it is 0 to pi by 2 minus integration 0 to pi by 2 minus cos x integrated function and differentiation of first function n x raised to n minus 1 dx. And if you apply the limits, this would be, if you observe, pi by 2 cos pi by 2, it is 0, this pi by 2 raised to n multiplied by 0 is 0 and lower limit also 0. So it is 0 minus 0, it is 0. So this is minus plus n 0 to pi by 2 x raised to n minus 1 cos x into dx. Now what you need here, x raised to n minus 2 means you need to integrate again. So I call this is u, this is v, and again integrating by parts. So this would be something, it is x raised to n minus 1 constant by parts, u constant, integration of v, it is sin x and limits applied 0 to pi by 2 minus 0 to pi by 2 sin x as it is integrated or primitive, and first one differentiation x raised to n minus 1, it is x raised to n minus 2, n minus 1 x raised to n minus 2, and with respect to x. So what happens here? See, this would be bracket complete. This is equal to n. If you apply upper limit, it is pi by 2 bracket raised to n minus 2 sine pi by 2 is 1, and lower limit value would be 0 minus this is n minus 1 integral 0 to pi by 2 x raised to n minus 2 into sine x into dx. Okay. Now I simplify this further. N bracket raised to n minus 1, then n multiplied here, n minus 1, it becomes 0 to pi by 2 and x raised to n minus 2 sine x dx. Now if you observe this, this is for in. Now this is replaced by in minus 2 from expression number 2, and I am getting this as this particular form. In is equal to n pi by 2 bracket raised to n minus 1 minus n minus 1 in minus 2. So this is required reduction formula which is desired, and suppose you need to find value for some n, then I6 or I2, I4. You can just work out by recurring it. Suppose I4 it is required, then put n equal 4, 4, then 3, then 4 into 3, 12. It is something like this. You can just work out, go on recurring and get the values, previous value, then earlier value, and so on. Okay, so let us stop here.